This demonstration is being done for two reasons. The first is to show how a system using a primer can be done in one day using epoxy as a base and then polyaspartic body coat and polyaspartic top coat. The base being an epoxy, of course, will take the longest to cure before the next coat can be applied. But as the demonstration will show, it is possible to go wet to wet with the polyaspartic body coat over the epoxy primer coat. The process starts here with a diamond grind. The whole idea here is just to give it a cursory pass with a 16 grit on a 6-tool rotary machine. Take off any surface contamination, any elevation inequalities that would otherwise affect the adhesion of the primer coat. Once the grinding is finished, a vacuum wand is passed over the surface to pick up the bulk dust. Once the wand vacuuming is completed, a shot blast is done to de-dust the surface. This process is going to recover the fine dust that the wand vacuuming could not, because a diamond grinder normally, as it makes the dust, it's packing that dust back into the holes of the concrete. This particular slab has holes that are quite large. Other slabs may not have the same amount of porosity that this particular concrete does, but in any case, whenever a grinder goes over a floor and it makes dust, it usually will pack that dust into the surface pores of the concrete. The shot blaster, being that it's made to agitate the surface under negative pressure, will extract that dust that the wand vacuuming simply could not. Once the magnet card is passed over the surface to pick up the loose shot that's left behind after blasting, the primer can be applied. The primer that's being used is 100% solids universal epoxy. For the purposes here, it's simply being used to fill in the holes that are inherent in the slab surface. The idea with the epoxy is to make a pass with that material over the top of the concrete so that those holes will be filled in. By filling those in, and then of course when the epoxy hardens, it's going to form a nice network of capillaries of the surface of the concrete that have been fortified with the epoxy, which once it's hardened is going to be harder than the concrete itself. So it establishes a nice sound base that the next coat is going to be able to anchor to. Once the epoxy has had time to soak the floor and to start to set up a bit, about an hour and a half in this case, it's time to put down the polyaspartic base coat. The polyaspartic is being mixed 1-to-1 to make 1 gallon of material, plus the additive color of white to coordinate with the flake. The area is just over 150 square foot, and the aim is to be somewhere around 8 to 10 mils thickness. So the 1 gallon over 156 square feet, plus the color additive, it's going to be in the neighborhood of 10 mils. There will be some left over, some lost to the roller, but the aim is for an 8 to 10 mil body coat. The material is dipped and rolled as opposed to dumped and squeegeed, because working by myself, it's easier and more controllable for the material to be dipped and rolled and then cross-rolled to take out any ridges that might be left behind during the initial application with the roller. Immediately following this, because polyaspartic tacks up pretty quick, vinyl chip is broadcast to full saturation of the surface. The other thing that's being tested is the idea that a floor can simply be vacuumed as opposed to scraped and vacuumed. So only half of this floor is being scraped by a blade, or in this case a trowel, and the other half is being left as is and simply being vacuumed. After about an hour and a half at 60 degrees, the polyaspartic is hard enough to be scraped, but with great caution. If I need to wait a little bit longer so that I can get a pole scraper on there, which would be more productive, maybe more effective, then I could add another 30, maybe 45 minutes, and then probably have a better surface that can bear the weight of the scraper without it doing damage. Running short on time for the time of the day that it started, it's being scraped by hand. Once the scraping and the vacuuming is finished, a polyaspartic top coat is applied. It's the same material as was used for the flake coat, except this time it's going to be applied clear. This area is 156 square feet. 2 gallons are mixed up to account for the amount that the flake that's not been scraped and only vacuumed, for how thirsty or the amount of air that's trapped below that flake, as well as the 1/4 inch nap 18-inch roller and how much of the material is going to be lost inside that roller. It's not an exact science, but the goal is to not run out. With polyaspartic, I don't want to run out in the middle of an application because I run maybe a quart short. I'd rather have more than I need. I can lose the excess material off the far side of the demo area. The polyaspartic is applied by dumping it on the surface and then using a decorative squeegee to drag the material across the flake, medium pressure. As it sticks or absorbs in, then that's the amount that the floor takes. But the expected consumption, which is usually easy to predict, is about 100 square feet per gallon. Inspecting the floor the next day, it becomes quickly obvious why a floor is scraped and vacuumed. The area that was scraped and vacuumed looks more uniform, doesn't appear to have any flakes that are sticking up that would create those sharp edges. The far side that was only vacuumed, there are numerous flakes that are sticking up that are sharp. With enough pressure and enough speed, definitely would cut the skin. That's just the reason that the scraping is normally required for any flake floor, or if not scraped, then maybe sanded. But some kind of mechanical action to break off any of that rough flake, because the result, again, is going to be flakes that are sticking up and will be rough, if not dangerous, for people to walk on. All in all, it was a successful demonstration. The main goal was to show that a floor that is a polyaspartic flake could also be done using an epoxy primer. By combining the two, though, I'm able to get that firm foundation of epoxy base, which again doesn't dry right away and will be wet when I apply the polyaspartic, but I get a good soak of the surface of the concrete with that epoxy. The polyaspartic body coat that gets the flake thrown into it, it is something that within an hour and a half can then be scraped that day and then top coated the same day, and then left for the customer's use after probably to be safe, 2 days to reach a full cure. In 3 coats, I'm finished, and I have a floor that is fully sealed and should be every bit as durable as a floor that receives maybe more coats, without a doubt more durable than a floor that only receives 2 or uses the body coat as the primer and the flake layer. Thanks so much for watching. If you like what you watch, please drop a like below. If you have any input based on your experience, that's always welcome too. Thanks very much and have a great day.